Hello everyone, I am Parth Rajendra Rao. Currently I am studying in second year BTech in Electrical Engineering of KBT College of Engineering, Nashik. Today we are going to discuss on design on-grid solar PV system for household. So today's presentation gives us a knowledge about rooftop solar fitting, subsidies provided by the government, selection of perfect solar panels, selection of inverters. So let's get start with our presentation. Here is the overview of today's presentation. First, we will see user information, then electricity tariff, solar module selection, system configuration, energy generation calculations, and defining the connection type, economic benefit, and environmental benefits. So, we will start with our user information. User information, we will obtain this information through utility energy bill that we received every month by our utility company. Here is my energy bill, means I use my own personal energy bill for calculation of this. We have the sanction load of about 1.3 kilowatt. Then our average monthly consumption is about 76 kilowatt. This we will calculate using our data in energy bill. In our energy bill, we will see our last 12 months data. This I will mention here from October 24 to September 25. Data is given on the energy bill. Our consumption of September is 64 units or 64 kilowatt hour because one unit is 1 kilowatt hour. Then 68, 65, 24, 103, 119, 86, 46, 32, 64, 70, 68. So to calculate our annual energy consumption or monthly energy consumption, this is the formula summation of consumption. We will say it K, summation of K divided by month. We will say it N. So the summation of consumption is 872. We will put this in formula 872 divided by 12. Our answer is almost 76. It's round figure, 76 kilowatt hour. So this will be our average monthly consumption. This is very important figure. This both is very important figure required in further slides. Let's move on to the next slide. Sorry, electricity tariff. So firstly, we will have to understand what is tariff. Tariff is a rate at which utility company charges for the consumption of electricity. In Maharashtra, we will purchase electricity from Mahavitaran or Mahadiscom. Mahadiscom uses the block rate tariff method to charge us. In block rate tariff method, tariff for first 100 units is 4.82 plus 20 paisa means 4.48 rupees per kilowatt hour means per unit. For 103 to 300 unit, the tariff is 11 rupees 10 paisa plus 0.40 paisa means 11.50 rupees per INR. Sorry, per kilowatt hour. So MSEB as means our utility company charges some fixed monthly charges like fuel and cost charges. Their multiple charges are listed on the back side of the utility bill and in Marathi or in the that energy bill there is a written like steel akar means fixed charges of rupees 100. So the fixed charges of 1 year is around 1200 rupees. This figure is also needed in further calculations. Next slide. We will discuss on tariff. So now selection of solar module. Which module is perfect to our rooftop? We'll see in this section. I selected the solar module, means solar panel of Waaree make. You will select of any make, but I'll find Waaree perfect in all the regions which I required. So the model name is Waaree WSMD 450. This all data which I mentioned here, you will get this data on data sheet. This is the data sheet of the Waaree company. I'll put it on the screen or give its link in description box. So uh, according to this data sheet, WSMD model, its model is monocrystalline PERC. So what is PERC? PERC means passivated emitter and rear cell. What is passivated emitter and rear cell? It means that suppose this is your solar panel, this is sun. Here is the radiation is falling on the surface of the solar panel. This is the stand means support to solar panel, and this is rooftop. In this PERC technology, sun rays get uh, as it is fall on the surface and get reflected towards the solar panel. So it's passivated cell and rear cell does the same as your solar panel does. Means it's again convert that reflected energy into electricity. Means you are utilizing solar panel from both the side. Due to this, our efficiency is increased little bit. This model has 20.5% efficiency. If this is non-monocrystalline PRC module, its efficiency lies between 15 to 17%. So by using this technology, we will increase our efficiency by 5%. This 5% matters a lot in solar technology or rooftop fittings. So this module, as per datasheet, this module has the voltage at maximum power. Here one graph is there in selection while selecting solar panels is maximum power point tracking. See, this is power, its time, or its solar irradiation. When power increase, as solar irradiation increases, this power also increases. But there is a one point on which the panel gives us the maximum power. So what is voltage at maximum power is 41.8 volt. Means at maximum power our panel delivers us 41 volt. Same with current, IMP means maximum power current. Current at maximum power is 10.77 ampere. Open circuit voltage is necessary or it's crucial parameter while selecting solar panels. So our open circuit voltage is 50.10 volts. Our short circuit current, we measure voltage by open circuit test and current by short circuit test. So as per short circuit test, our current is 11.46 ampere. Temperature coefficient. Temperature coefficient means change in solar output by per degree Celsius change in temperature. Percent change in solar output by per degree change in solar irradiation or per degree Celsius. This temperature coefficient is better as the lower means as lesser the number, greater or best the solar panel has. This is in negative, so it's best in sector. Try to get least negative number or maximum negative number. Warranty. A company offers warranty of 27 years of output warranty. Here I written 25. It's 27 years of output warranty on performance. Not company not responsible for any damage or any other condition happens with panel. You are only able to claim warranty on the performance of panel. If this of any parameter get uh, changes or get reduced, you are able to claim the warranty towards the company. And product warranty means if any failure in the product happens, like this part is not generating electricity, or this kind of or many kind of problems happens with solar panels. So you will able to claim warranty until 12 years. Means company gives us 12 years of warranty for that reason. And this all the data is as per standard test condition. What is standard state conditions? Means company has the laboratories where they test their solar panels. In that test, company tests their solar panels in 6,000 watt per meter square, means 6 kilowatt of solar irradiation in 1 watt in 1 square meter area. This is standard test conditions called as STC. In datasheet, here mechanical characteristics also given like its weight, its 23 kgs, number of cells means 144 cells are installed, solar cell type, its monocrystalline PERC cell, its dimension 83 by 83 into 166 mm, front glass of low iron and tempered glass, PID free and UV resistance, IP rating is given, and frame is ionized aluminum alloy. The multiple data is given. I have also one research regarding solar radiation data of Maharashtra. I'll also pop up this on your YouTube screen. This also required in further slides for calculations. So now we see system configuration. How much panels we required, how much tilt angle of system are needed in Nashik to perfectly or to efficiently get output from the solar panel. So we are planned to using two solar panels of 450 watts. Multiple panels are available in the market like 250 watt, 250 watt, 450 watt, 500 or 550 watt, 750 watt, 1 kilowatt. Multiple ranges according to manufacturer varies and available. Here I only considered Waaree company. So Waaree, we are taking the two panels of 450 watt. It's equal to 900 watts means zero point 0.9 kilowatt. See, this panel is of zero point 0.9 kilowatt. Our means my energy output is almost zero point 0.8 kilowatt. Means here plus zero point 0.1 kilowatt. We are surplusing our power. System type is grid-tied rooftop solar PV system. See, we have to claim the subsidy from the government. Government only gives us subsidy when we are using this system type, means solar rooftop grid connected system. On off-grid solar system, government doesn't or not gives us a subsidy. So this is important. In grid connected system, you have the flexibility to use the utility power. But at the time of blackout or a power shortage or power cut, your home's power also get cut. Means grid supply is cut off, then the solar supply is also unusable to us. So that's why a new system is introduced in the market. It's off-grid solar system. In off-grid solar system, you are isolated from the utility grid. Means here is your home. It's powered by solar panel. You connect solar panel to batteries for storage. This batteries is utilized in night time when the light is not available. And here is the utility grid. See, your home is isolated from the grid. That's why it's called as off-grid. And in grid connected system, wait a minute. And in grid connected system, your system is permanently connected to grid. This is solar panel. This is inverter. This is net meter. Net meter calculates input energy from the grid, input energy from solar panel, how much energy you are utilizing from solar, how much energy you are utilizing from the grid, and net difference is paid or net difference is transferred to utility company for further calculations from their sides. So in grid connected system, here your solar panel is connected to your home through net meter, and net meter is also connected to utility grid. This system is offers high reliability. Inverter capacity, orientation. Orientation of a panels is south facing panels, and tilt angle is of 20 degree. Tilt angle varies according to your state, your city. In Nashik city, the recommended tilt angle is around 19 to 20 degrees. It's the angle where we are able to capture maximum solar energy, and south facing panels or south facing orientation we are implementing. In some countries or in some state in India, orientation may change according to their geographical location. Expected daily average solar radiation is 5.5 kilowatt per meter square per day. This value is also varies according to your location. In Nashik, it's 5.5 average. This is the data of solar radiation. I'll pop it up on the screen. In this data, you are able to calculate or you are able to see your average radiation data. In Nashik, it's 5.5. System losses. We consider some losses in system like wiring, inverter, temperature, etc. We consider losses of 15%, means ultimately our system efficiency is 85%. Inverter specification. We saw about solar panel, we saw configuration. So now it's time to take knowledge or learn about inverter. We are using the inverter of Growatt make model number is or model name is MIC 1000 TLX, as its model name suggests 1000 means its capacity is 1 kilowatt. Its nominal AC power is 1 kilowatt. Maximum power point voltage is around starting from 50 volt to 500 volt DC. Starting voltage is 50 volt, means the supply or the voltage of 50 volts appears across its input terminal. It gets started to deliver power to us. Firstly, what is inverter does? Inverter does the conversion of DC or direct current into alternating current. Maximum DC input voltage is 500 volt. Beyond 500 volt, it doesn't respond to input. Maximum input current is 13 ampere. Above 13 ampere, you would have to change your inverter. But we saw the calculation earlier, next slides, how why we selected this inverter. We have, sorry, I have data sheet of this inverter also. In this technical data is given. I'll again provide you link of this also. This data sheet shows all the configurations or all the specifications of that particular inverter. According to data sheet, its category of DC over voltage is category second, and it has IP rating of IP65. This rating is crucial when you are installing your inverter module. It's outdoor. It has the power factor of AC output power factor of 0.8 lagging or 0.8 leading. It's our nominal or it's our average household power factor. It's also giving us that as an output. It has maximum short circuit current of 16 ampere DC, maximum recommended PV power up to 1.3 kilowatt. Means we are not able to connect the system of solar panel above 1.3 kilowatt because recommended maximum power out input or power output of solar is only 1.3 kilowatt. So we are finally going with Growatt MIC 1000 TLX inverter. Energy calculation. So this is very important topic, energy calculation. In energy calculation, firstly, I'll refer to second slide of user data. In this, I'll calculated this all things like this our monthly consumption or required things like this, and solar irradiation data we have calculated in earlier slides. So energy output from the solar panel, formula for energy output is equals to output from photovoltaic cell into solar radiation into efficiency. So our calculation is zero point 0.9 into 5.5 into 0.85, its efficiency. So our rough total is 4.2 kilowatt per day. Means our output from the solar panel is 4.2 kilowatts per day. Monthly output 4.2 kilowatt into 30 days is 126 kilowatt. Our annual output is 126 into 12 means 1512 kilowatt hour. This much of energy we are able to obtain from our solar system. This our means my sample consumption bill is I taken as a sample which shows my consumption average consumption of year is 872 kilowatt hour, and we are obtaining 1512 kilowatt hour. Means we are surplusing some energy to sold or to sell it to utility grid. Means it's beneficial things. Due to this our payback period get reduced. Connection type. While installing solar, there are two type of connections. First one is the series connection, another is the parallel connection. In series connection, voltage get adds and current remains the same for two panels in series. And for parallel connection type, the current adds up and voltage remains the same for two panels. So we will see which is beneficial to us and which is compatible with our selected type of inverter. If we go with the series connection, we get the starting maximum voltage is 41 volt of one panel into two is 83.62 volts. Starting maximum current is 10.7 ampere because current remains same, so it's 10.77 ampere. Open circuit starting voltage is 50.10 volts into 2 for two panels is 100.2 volts. If you remember our data sheet of inverter, their nominal or starting volt is 50 volt, and we were obtaining 100 volts, means it's best voltage for operating our inverter. So for parallel type of connection, maximum voltage at starting is 41.81 volt. It's half that series type of connection. Your starting current is 21.54 amperes. See here, the maximum input current is 13 ampere. It means that this is this type of connection is not compatible with our inverter. Starting voltage, open circuit volt is 50.10 volt. Required inverter DC current is more than equal to 21.5 ampere. So our inverter supports only 12 amperes, so it's not safe to operate or not safe to connect this system with inverter. So we are going with the series type of connection. Our next slide is protection and component sizing. Which type of protection we are giving to our panel, our inverter, and which type of components we are using. We will see in this slide. DC starting fuse. Fuse at DC side means at the output of solar panel is of 15 to 20 ampere for positive terminals. Inverter DC input voltage range is 70 to 300 volts. We are obtaining this from our series connection. Inverter DC current rating is less than equals to 12 ampere. DC cable. We are using two type of cable here. First one is DC cable for DC side, and second one is the AC cable after the inverter at AC side. So at DC side, the cable required is of 4 square mm of copper type. It's rated for or it's ideal or it's suggested to use it for length for less than equal to 15 meters. Beyond the 15 meters, our system efficiency get ultimately or get reduced very significantly. AC cable is of 2.5 square mm copper cable. Yeah, we are using this cable to connect our inverter to ACDB. ACDB means distribution board, at which various multiple protection devices are installed like MCB, fuse, or MCCBs. Earthing, we are using the photovoltaic frame. We are going to earth the PV panel, our inverter, and ACDB. It must be properly earthed because to protect it from the lightning surge, lightning surges, overvoltage surges, transient voltage, it's necessary or it's highly recommended to use earthing with our solar system. So surge protector means SPD of type 2. We are using this on the AC side for surge protection purpose. So next, this is the single line diagram or block diagram of solar system, means on-grid solar system. Here, this is the sun, which is the primary source of energy, or it is the fuel. This is the solar panel, which we are connecting two panels of 450 watt in series, which gives us output of 900 watt. So solar panel is connected through the solar coupler to inverter, and inverter converts the direct current to alternating current. Here multiple protection devices like fuse of 15 to 20 ampere, and here the surge SPD surge protection device is used. So output of inverter is fed to net meter. Net meter calculates, as I said in earlier slide, calculates input energy from utility and output of solar panel or its input to net meter, and use the difference of these to your utility bill. If you are generating 1000 watts and you are utilizing 900 watts, so you are surplus 100 watts. So you are selling that 100 watts to your utility grid. In Maharashtra, MSEB doesn't pay you for selling electricity. The cost of bill is adjusted in terms of some points, or some energy calculation is done to adjust the bill cost or to reduce your energy bill. In some states, they pay you for the electricity at some cost of tariff. So, and in example two, if you are generating 1000 watts and utilizing 1100 watts, so you are it is at the negative 100 watts. So you are purchasing or you are utilizing this energy from grid. So you have to pay for that 100 watt to utility grid. This is the very simple explanation about the single line diagram or block diagram of solar PV system. So our next topic is economic analysis. This is very crucial, or this is a very important topic for selecting solar panel. Here we are purchasing the solar PV modules of 450 watt of Waaree monocrystalline type. One panel cost us 10,199. Two panel cost is 20,398 rupees. Inverter of Growatt 1 kilowatt single phase on grid inverter cost us around 16,872 rupees. Structure. Uh, to save space on our rooftop, we are using elevated or we are installing elevated type of structure. Here, two structure are comes with the solar panel. First one is only has around less than a 1 feet elevation from your rooftop, and this structure is have elevation as you require. Means if you wish, it has 7 feet taller, it has 10 feet taller. It depends on your use cases. So I am using the elevator structure. This structure cost me 10,870 rupees. BOS components. Under the BOS components, various components like comes like DC and AC cables, connector for it, electrical materials, and much more. So it cost me 5,000 rupees. Earthing and protection system. In earthing system, first and crucial component for solar panel is lightning arrestor LA to protect the panel from the lightning surge. Two earth pits, surge protection device, and isolator. These major components comes. This cost is around 6,000 rupees. Net meter and legal charges. Net meter and legal charges means purchasing or rental cost of net meter, and legal documentation charges with Mahavitaran cost me around rupees 2000. Miscellaneous charges like transportation, nut and bolts, fitting charge, etc. cost me around 5000 rupees. So our total cost of installation is around 66,140 rupees. Our government gives subsidy under PM Surya Ghar Muft Bijli Yojana. In this Yojana, total 30,000 per kilowatt subsidy is provided to household for installation of rooftop solar panel of on-grid type only. For second kilowatt means if you are installing 2 kilowatt system, you will able to claim subsidy up to 60,000 rupees, and for third kilowatt it's only 18,000. Means total 78,000 rupees we were giving, able to get from the government. So in my case, I'm installing 1 kilowatt system. So government gives me rupees 30,000. We are subtracting subsidy from total cost. Total cost is 66,140 rupees. So net payable cost is 36,140. This amount is only going out from the my pocket. So I'll only pay 36,140 rupees. This our economical analysis is done. Now we see how much uh, money we are saving annually and what is payback period of that system or return of investment on that system is. Annual savings means the formula for annual saving is firstly we have to calculate gross savings. Gross savings means annual output of solar panel into tariffs of our utility company. So our annual generation is 1,512 kilowatt and our tariff is 4.48 rupees. So this gives the rupees 6,773.76 Indian rupees. So net annual saving is gross saving minus fixed charges. As I told you in second slide, our utility Mahavitaran charges 100 rupees per month fixed charges. So these fixed charges I include here. Gross saving minus fixed charges. Our fixed charges is rupees 1200. Hmm. So 6,773.76 minus 1200 is 5,573 rupees per year. Means if I install this configuration of system on my rooftop, I'll able to save rupees 5,573 rupees on my energy bill per year. So now we calculate payback period. To calculate payback period, what you will have to do is net capital divided by your net annual savings. So our net cost is around what is 36,140 rupees divided or divide by 5,573 rupees. So it's around 6.4 means 6.5 years. So in 6.5 or roughly in 7 years, I'll recover all the invested money from my solar rooftop installation. We will move forward. Environmental benefit. In electricity, here two parameters are very important. First one is economic benefit and another is environmental benefits. In economical benefits, we will see how much money we are saving per year, but our environment is also important. So we have to analyze our environmental benefits also. So in environmental benefit, this data is calculated from the government website of new and renewable energy is expected. My expected annual generation is 1,512 kilowatt. Means it reduces 1.2 tons of carbon reduction per year. Means if I do not generate that electricity from renewable way, I'll if my utility feed me that electricity from any coal-fired thermal power station, means I my household generate 1.2 tons of carbon reduction per year. So you are able to see how much we are protecting our environment. It's equivalent to 18 trees plant per year. Hardly we we plant one or two trees per year, but by only installing the solar panels, this equivalent to 18 trees plantation per year. This solar installation contributes directly to reduction in fossil fuel dependency and promotes sustainable use of energy. So that is our today's topic. I hope you will like this video. Thank you for watching. I'll share all these data sheets on description box for further references. Thank you once again for watching video.